Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions on mechanics and waves from October-November 2022, Paper 2, Variant 2. In today's lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these questions and also these topics. Let's study together. Let's improve together. For our third question, part A, we need to state what is meant by the center of gravity of an object. Center of gravity of an object is very important point, and it has many applications in real life, and also it's play very important role in designing a lot of equipment. So what is center of gravity? Center of gravity is a point where all the weight of the body can be considered to act. That point we call is center of gravity. Center of gravity we can also define in a little bit different way. Center of gravity is a point through which a single force will create no turning effect. So let's try to find out center of gravity of this pen. So I will slide my finger under this one. You see, if I apply a single force here, there will be turning effect. It will go this way. So I will slide under this one. I will reach a point. And if I apply a single force at that point, there will be no turning effect. And that single point is this one. So you can see at this point, I'm applying a single force that is acting vertically upward, and there is no turning effect. So this is center of gravity of this pen. Center of gravity, it can be outside of the body, it can be inside the body. Now let's go back and try to write down answer for this question. This is how we can write down answer for this question. Simply you need to say that is a point where all the weight of an object is taken to act, or you can say is considered to act, and that point is center of gravity. And for this 30 centimeters meter rule, you can see its center of gravity is located at 15 centimeters because its density is uniform. If the density is uniform, it's a uniform meter rule. It simply means that center of gravity and the midpoint of the meter rule, they will be at the same point. So center of gravity, in this case, if it is the uniform meter rule, means its density is uniform. So center of gravity will be at midpoint of that object. Midpoint will be at midpoint. So in this case, it is at the midpoint because it has a uniform density. Or simply you can say this is a uniform meter rule. For part D1, we need to calculate the vertical component of the force exerted by the wire on the beam. So this is the wire. So wire is exerting force of 45 newtons at an angle of 37 degrees with horizontal. We need to find out its vertical component. So simply we can resolve this one into vertical component, and also we can resolve into horizontal component. So it has vertical component and it has horizontal component. For this question, we need to calculate its vertical component. So this component will be horizontal, this one will be vertical. So this is simply 45 cosine of 37 degrees, and this one will be 45 sine of 37 degrees, and this is simply what we need to write down. So we will say vertical component in this case, vertical component of force in this case will be equal to 45 sine of 37 degrees, sine of 37. And if we solve this one, our answer will be 27 newtons up to 2 SF. So this is our final answer. So this is how you can find out. For the second part, we need to calculate the weight W of the block by taking moments about it. So simply we need to take moments about this point, and sum of clockwise moments has to be equal to sum of anti-clockwise moments because this beam is in equilibrium. And also it is given to us that this beam is uniform. So it simply means that its center of gravity is at its midpoint. So the distance from the wall to this point, if we draw a dotted line here, we can say this distance is equal to 0.48. So this distance is equal to 0.48. We can simply draw a dotted line here from this wall to the center of gravity. So this distance is 0.48. So this is 0.48 meters because total length of the beam is 0.96. Now there are three forces. Weight is acting here, and this distance is 0.56. So this will be 0.76. And there is a force due to this wire, and we can resolve that force into components, vertical and horizontal. So this is the vertical component. Due to vertical component of this force, there will be moment, but there is no moment due to horizontal component, because horizontal component is simply passing through the pivot point. So we can draw horizontal component here as well. Now simply we need to take moments. Moment due to weight of the beam, this will be clockwise. Moment due to this weight of the block, this also will be clockwise. But moment due to vertical component of force due to this wire, this one will be anti-clockwise. Now simply we need to equate clockwise moment and anti-clockwise moment. First of all, we can write down for this weight of the beam, this is clockwise, so 23 times we have 0.48 plus we have this clockwise moment, that is W, times 0.56 plus 0.20, it means this is 0.76, and this one has to be equal to moment due to vertical component. Vertical component we have calculated, that was 27 times this distance, that is 0.56. So this is 0.56. Now simply we need to solve for W, and our answer in this case will be equal to 5.4 newtons up to 2 SF. So our answer is 5.4 newton. So this is how you can figure out. For third part, it is given to us the hinge exerts a force on the beam at end A. Calculate the horizontal component of this force. So first of all, we need to understand, as this beam is in equilibrium, it simply means that the sum of the forces along horizontal has to be equal to 0, and sum of the forces along y-axis also has to be equal to 0. So now simply we'll need to look at horizontal component of the forces. In this case, this force has no horizontal component. This force has no horizontal component. Only force due to wire, this one has horizontal component. And direction of horizontal component is to the left. So in order to balance this one, there must be horizontal component of force due to hinge at this point, and that one has to be to the right, and these two components, they have to be equal in magnitude but opposite in direction. So it simply means that the horizontal component of hinge force, we can say FH, that one will be equal to 45 cosine of 37 degrees. So that's all what you need to understand. If we solve this one, your answer will be 36 newtons up to 2 SF. So this is our final answer. Now if we go to the next part, part 4, the block is now placed closer to point E. Closer to point E means we move this block this side. So imagine that this block is placed here now. So we move this one to the left. State whether this change will increase, decrease, or have no effect on the tension in the wire. But we need to understand, in this case, the beam is still in equilibrium. Still in equilibrium. So first thing, we need to look at the moments. Moment due to weight doesn't change because force is the same, distance is the same. Moment due to W, due to this W, it has decreased because this is the same, but this distance has been decreased. So the moment due to this weight of the block has been decreased. Now we need to look at moment due to vertical component, or simply we can say moment due to force in this wire, and that distance doesn't change, means the distance of force from the pivot, it doesn't change. So it means this force has to decrease because this distance decreased, so this force has to decrease because the distance of this force from the pivot does not change. So it simply means that in this case, tension in the wire, it will decrease. So simply you can see from here, tension in the wire has to decrease because this distance has been decreased. So the moment, net moment, has to be equal to 0. So this force has to decrease in magnitude. So simply in this case, we can say tension in the wire decreases. Tension decreases, or you can say tension in the wire decreases. So this is how you can approach this problem. For part 5, it is given to us the stress in the wire is 5.3 times 10 to 7 Pascal. The wire is now replaced by a second wire that has a radius that is 3 times greater than that of the original wire. The tension in the wire is unchanged. Calculate stress in the second wire. So quite straightforward question. Radius has been increased by 3 times, but tension is the same. So it means that area has been increased by 9 times. So stress will decrease by 9 times. So simply this is how you can answer. So let me explain you this one step by step, because this question has 2 marks, so you need to write on this one in a proper way. So the first thing we need to understand, stress, simply stress, this is equal to force over cross-sectional area. In this case, force is the same. Force is same. So we can also write down sigma for stress. We can say this is equal to force over cross-sectional area. In this case, F is the same. So we can say the product of stress and cross-sectional area for 2 wires is the same. So this one is constant. So simply we can say this one is constant. So we can write on here. So we can simply say in this case sigma 1 A1, this one has to be equal to sigma 2 times A2. So we can change this here. Area, we can write down this is pi r square. We can say r1 square. And here we have this is value of sigma 2. And we can write down this is pi r2 square. But in this case, r2 is equal to 3 times of r1. So we can rewrite this one. So we can write down sigma 1. So we have here sigma 1. Here we have pi r1 square. This will be equal to sigma 2, and here we have pi, and this is 3r1 square. And so we will get here this is sigma 1, and here we have pi. You can simply cancel with this one. So we left with r1 square, and here we have this is sigma 2. So we can write down sigma 2 here, and we will have 9 times r1 square. So r1 square, we can simply cancel. So from here we can get sigma 2, that will be equal to sigma 1 divided by 9, and sigma 1 is given to us. The value of sigma 1 is given, that is equal to 5.7 times 10 to 7. Just simply divide by 9 and we can find our final answer. Final answer in this case will be equal to 5.9 times 10 to 6 Pascal. Actually this is 5.3. Sigma 1 is 5.3 times 10 to 7. So this is our final answer, and this is how you can figure out 5.9 times 10 to 6 Pascal up to 2SF. So this is how we can approach. This question is very straightforward one, because in this case F is same. So if this increase by 9 times, this one has to decrease by 9 times. So simply you have to divide this stress by 9 and you can find the final answer. For our question number 4, it is given to us a horizontal spring is fixed at one end, a block is pushed against the other end of the spring so that the spring is compressed as shown in figure 4.1. And it is also given to us the block leaves the end of the spring with a speed of 2.3 meters per second as shown in figure 4.2, and mass of the block is given, that is equal to 250 grams, and spring constant is given, that is equal to 420 newtons per meter. It is also given to us the spring obey Hooke's law. For part A, we need to calculate the kinetic energy of the block as it leaves the spring. So quite straightforward question. We have speed of the block and we have the mass of the block. So simply you need to use kinetic energy formula. Ke is equal to 1/2 mv square. It is very important you write down the formula because it has marks. So always write down the formula, then plug in values and then do calculations. And then you can write down your final answer. Kinetic energy we need to calculate in this case. So simply this is 1/2 and the mass is given in grams. So we can convert into kilograms. So this is 0.250 and speed is given in SI base unit. So simply you can write down this is value of speed. And now if you do calculations, in this case our final answer will be 0.66 joules up to 2 SF. Because raw data, the least number of SF in raw data is 2 SF. So our final answer also should have 2 SF. So this is final answer for this question. For the second part, we need to calculate the compression of the spring immediately before the block is released. So it simply means that first of all, we compress the spring, we move this block to the left. So imagine that spring is fully compressed when the block is at this point. And question is asking us to calculate this amount of compression because at this point, the block is leaving the spring, means the spring is fully extended at this point. So we need to calculate value of X. In order to calculate value of X, at this point when the block is here, spring is fully compressed. So the energy stored in this system is equal to EPE. And at this point, the spring is not extended and not compressed. So the energy in the system is stored in form of kinetic energy. So simply in this case, we can say elastic potential energy, this is equal to kinetic energy. And kinetic energy we have already calculated. We have the value of kinetic energy. So EPE, we can say this is 1/2 K times x squared. And kinetic energy we have already calculated. That was equal to 0.66. So in this case, it is also given in the question that all the EPE has been converted into kinetic energy. So in this case, there is no loss of energy due to friction. We need to calculate in this case value of x. So we can rearrange this one for x. So we can write down in this case x square. This one will be equal to 2 times 0.66 divided by k. So this is k. We need to calculate x. So we have to take square root on both sides, and we can also plug in values of k. K in this case is equal to 420. So if we take root of this one, 1/2, we can find value of compression, and compression will be equal to 0.56 meters up to 2 SF. So this is our final answer. So we can write on here 0.056. So this is the final answer. For part C, it is given to us after leaving the spring, the block moves along the surface until it hits a barrier at a speed of 2.3 meters per second. The block then rebounds at a speed of 1.5 meters per second, moves back along its original path. The block is in contact with the barrier for a time of 0.086 seconds. We need to calculate change in momentum of the block during the collision. So simply we can imagine that there is a barrier. So you can simply imagine here is a barrier, and this block hit this barrier with speed 2.3 meters per second and rebound with a speed of 1.5 meters per second. We need to calculate the change in momentum of the block. In order to calculate change in momentum of the block, simply we can say delta P. This will be equal to m times v minus u. In this case, mass of the block is 0.250 kilograms and the final speed. So we need to take one direction as positive because momentum is a vector quantity. So we will take in this case to the left positive. So our answer will be positive because to the left is direction of resultant force. And so we will take to the left positive. So our answer will be positive. So it simply means that this value is positive and this value is negative. So simply we can plug in values. We have 1.5 minus into we have minus 2.3. Now if we solve this one, our final answer in this case will be equal to, let me write on one more step. So we will get 0.250 and here we will get 1.5 plus 2.3. And if we solve this one, our final answer up to 2SF will be equal to 0.95 newtons second, because this given unit is Newton seconds. So this is 0.95. And this is how you can approach. Only tricky part in this question is direction. Momentum is a vector quantity, so you need to take one direction as positive. And change in momentum, direction of change in momentum is the same as direction of change in velocity. So in this case, resultant force on the block is to the left. So we have taken to the left positive. So our answer is positive. If you take to the right positive, your answer will be negative, but magnitude will be the same. For the second part, we need to calculate the average resultant force exerted on the block during the collision. But we have already calculated change in momentum and the time of impact is given to us. So simply we can say in this case, the average resultant force exerted on the block will be equal to the change in momentum divided by time of impact. So simply average resultant force is equal to rate of change in momentum. And change in momentum we have calculated, that was 0.95, and the time of impact is given to us, that is equal to 0.086 seconds. So if we solve this one, our final answer will be equal to 11 newtons up to 2 SF. So this is our final answer. So this is how you can figure out average resultant force. For part D, it is given to us the maximum compression X of the spring is now varied in order to vary the kinetic energy of the block as it leaves the spring. Assume that all the elastic potential energy in the spring is always transferred to the kinetic energy of the block. On figure Figure 4.3, we need to sketch a graph to show the variation with x of Ek. In this question, it is given to us that Ek is equal to EPE. So we can write down EPE in terms of x. EPE is equal to 1/2 kx squared. So we can simply say, in this case, Ek is directly proportional to x squared because k is constant and 2 is constant. So simply the shape of the graph has to be parabolic with increasing gradient. So when x is equal to 0, Ek also equal to 0. So gradient has to increase because it has to be parabolic. So this is how you need to sketch. So if you sketch like this, you will get 1 mark because this question has only 1 mark. For question number 5, part A, it is given to us two progressive sound waves meet to form a stationary wave. The two waves have the same amplitude, wavelength, frequency, and speed. State the other condition that must be fulfilled by the two waves in order for them to form a stationary wave. Two progressive waves, they can form a stationary wave if they have the same speed, they have the same amplitude, they have the same wavelength, and they have the same frequency. Only if these two waves, they are traveling in opposite direction, then they can form a stationary wave. So simply for this question, you need to write down travel in opposite directions. So those two waves, they have to travel in opposite directions. If they travel in opposite directions, they can form a stationary wave if they have the same amplitude, same wavelength, speed, and frequency. Travel in opposite directions. So we can say travel in opposite directions. For part B, it is given to us a stationary wave is formed on a string that is stretched between two fixed points A and B. Figure 5.1 shows the string at time t is equal to 0 when each point is at its maximum displacement. Distance AB is given that is equal to 0.80. The period of the stationary wave is 0.016 seconds. For part B1, on figure 5.1, we need to sketch a solid line to show the position of the string at time t is equal to 0.004 second. Label this line P. Time 0.004 second. And this time, because in this case we have time period that is equal to 0.016 seconds. So the time, this time 0.004 second, this given time, this time is equal to t by 4. So this is equal to t by 4. So this is first thing we need to understand. Now we need to understand where this string will be after t by 4. If you look at this particle, for example, after t by 4, this particle will be here. So this particle will go up and this particle will reach this point. And all the particles between these two nodes, they will reach this equilibrium. All the particles, I mean, if I take one particle here, this will go up. After t by 4, this particle will be here. And if I take particle here, after t by 4, this particle also will be here. And same is true for this node and this node. So particle at the top, this will come back to equilibrium after t by 4. And it is also true for other particles in this loop, mean between these two nodes. You can also take particle here after t by 4, this will come here. Because all the particles between two nodes, they are always in phase. If you look at this loop, mean between these two nodes, this node and this node, the particle at the bottom, after t by 4, this particle will be here, and particle on the string at this point, after t by 4, this will be here at equilibrium. And same is true for this one. We can also repeat this one. It's the same. So if you got this idea, that's wonderful. And particle here after t by 4 will be here because this particle go down. Particle here after t by 4, this one will be here. So it simply means that after t by 4, all the particles, they will be at equilibrium. So simply in this case, we can draw a line, solid line. So we will draw a solid line here. So this is what you need to do for this question. So you have to draw this line. So we have done this part. Now let's go to the next part. At time t is equal to 0.024 second, label this line Q. So this line we have to label P. So we can label this line is P. And now we go to the next one. We will answer next problem now. This one. Here we need to understand T is given to us. This T is equal to 0.024 seconds. We can write down this one in terms of time period. Time period is equal to 0.0016 plus we have 0.008. So this is T by 2. So we can simply say we have 1T plus we have T by 2. So this is the thing you need to understand. Now it simply means that after one cycle, this particle, let's say if we look at this particle, after one cycle, this particle will be at this point again because it will complete one cycle. It will go up and come back to this one. So after one cycle, what we will see, same wave we will see, means we will see this shape of the string after one cycle. But now we need to understand this part. We need to understand T by 2. T by 2 means that after T by 4 this particle will be here, and after another T by 4 this particle will be at the peak at this point. Particle will reach at this point because it will take T by 4 to reach equilibrium, then again T by 4 to reach this peak. So this particle will be here. So we can draw here, and this particle after T by 4 it will be here, and after another T by 4 this particle will be at this trough, mean lowest point. And this particle T by 4 here, another T by 4, this particle will be here at this point. And this particle after T by 4 here, after another T by 4, this also will be at the lowest, it means at the bottom here. Now simply we need to connect these points, and to connect these points we will use pink color. So particle here, it will just stay here, particle here, this is at the node, this particle will not move, this particle will not move, this particle will not move because its displacement is 0. So simply we need to connect these. So we can simply connect like this. So we can connect. So this is what you need to draw, and this wave is Q. So we will say this one is Q. So this is how you need to label. I hope this one is clear to you. Beautiful question about stationary waves. So if this question is clear to you, it means you have good understanding of stationary waves. So you need to understand particle between any two consecutive nodes, they are always in phase, and particles on the two sides of any node, they are in antiphase. So when this particle is moving up, this particle will be moving down because they are on two sides of the same node. And same is true for this particle, and for this particle, any particle, they're always in antiphase. So these points are very important. If I look at this particle, if I look at this point, I mean this one is the node, all the particles in this loop and all the particles in this loop, they are in antiphase, means they have phase difference of 180 degrees. For the second part, we need to determine the speed of a progressive wave along the string. But for this question, it is given to us the distance between point A and P. This is equal to 0.80. So L is given to us. So L is equal to 0.80 meters. And L in this case, this is equal to 2 lambda because this is one wavelength and this is another one. So 2 lambda is equal to 0.80. So lambda simply is equal to 0.40 meters. And time period is also given to us. Time period is equal to 0.016 seconds. And question is asking us to calculate speed. So speed simply is equal to lambda over time period. Lambda is 0.40 and time period is 0.16 seconds. So the final answer in this case is 25 meters per second, and this is speed of progressive wave. For part C, it is given to us a beam of vertically polarized light of intensity I naught is incident normally on a polarizing filter that has its transmission axis at 30 degrees to the vertical as shown in figure 5.2. So as you can see, this angle with vertical is 30 degrees. It is also given to us the transmitted light from the first polarizing filter has intensity I1. This light is then incident normally on a second polarizing filter that has has its transmission axis at 90 degrees to the vertical. The transmitted light from the second filter has intensity I2. First of all, for part C1, we need to calculate ratio between I1 and I0. So this question is simply about Malus' law. So first of all, let's try to understand a little bit about Malus' law. According to Malus' law, I transmitted. So we can say I transmitted. So this is I transmitted. I transmitted is equal to I incident. So this is intensity of incident light time cos square theta. And theta is the angle between two polarizing filters. Or you can say one polarized light and the polarizing filter. So in this case, we have vertically polarized light. So we have vertically polarized light, and angle with vertical means with this vertical and this polarizing filter, the angle between transmission axis. So we can say angle between transmission axis. So we can say transmission axis. So in this case, we will say transmission axis. Transmission axis. So polarized light. So this means polarized light. This is the angle between two transmission axes. So we can say this is polarized light. Angle between polarized light and transmission axis. And that angle in this case is given, that is equal to 30 degrees. So simply in this case, this is transmitted. So we can say I1. This one has to be equal to I0 cos square of this angle. That is 30 degrees. So this is the angle between two transmission axes. And so this is 30 degrees. Simply we need to find out I1 over I0. So we have to take cos square of 30 degrees. If we take this one, our final answer will be 0.75. So this is what we need to do for part 1. For the second part, we need to find the ratio between I2 and I0. So we will start from I1 first of all. So first of all, we will look at this part. This part we will look first of all, and then we will go to the second part. So this will be our second part. So we will divide into two parts. So we will say this is first part and this one will be the second part. If you look at first part, we have already done that I1, this is equal to I0 cosine square of 30 degrees. And we have already found that I1 is equal to I0 and cosine square of 30 degrees, this is equal to 0.75. So simply we can write down, in this case, I1 is equal to this value. And now we can go to the second part, this part. So in this case, our incident is I1 and transmitted is I2. So we can again use Malus' law. We can say I2 will be equal to I1 and angle. This angle with vertical is 30 degrees and angle of this transmission axis with vertical is 90. So the angle between these two transmission axes, this is equal to 60 degrees. So we will be writing here the angle between these two transmission axes is equal to 60 degrees, because angle of this one with vertical is 30 degrees and angle of this one with vertical is 90. So the difference between these two, angle of transmission axis, that is equal to 60 degrees. So we can write down, in this case, I2 and this is equal to I1, and now we will replace I1 with this. So we will replace this. So we can write down, this is I0 0.75 time we have cosine square of 60 degrees. Now if we solve this one, we can write down I2 by I0. This is equal to 0.75 times we have cosine square of 60 degrees. So if we solve this one, our final answer will be 0.19, and this is how you can approach this type of problems. So the final answer for this one is 0.19. Then that's all for today's lesson. I hope you have better understanding of these questions, and also you have improved your conceptual understanding of physics. If you found this video helpful, then please like and subscribe. See you in next video.